Hey guys, it's Monday, March 30th. Welcome back to Algebra 2. Sorry that I missed you guys a little last week. I was busy taking care of some family stuff. But here we are. I hope Miss McKibben was kind to you guys as far as the lessons that she was presenting. I'll try not to mess you guys up too much. But today we're going to do some solving equations. And as usual, remember, when we solve an equation, and this will pop up again in a few minutes, we're going to use SADMEP to help us make sure we're doing the right things in the right time, okay? So remember that it's subtract, add, divide, multiply, exponents, and then last we have parentheses. I got to do all that one. Okay. Today, as we're doing this, we're going to treat the word log as a parentheses. Okay. So we'll get into that in the next slide as well. So let's go ahead. We'll start solving equations and see how we do. Here's the basics. Yes, again, we're going to use SADMEP as our primary way to remember how to solve these equations. Our log, L-O-G, our logarithm, you'll see L-O-G in the equations because these are logarithmic equations. This is going to act as a P, as in parentheses. So we'll do everything outside of the logarithm first before we get to the logarithm. Page 10 in the packet has a flow chart for solving equations if you're interested in looking at that. We want to make sure we take care of any condensing. We need a single logarithm on each side of the equation before we can start solving. And we're going to want to rewrite. Once we have those logarithms, we're going to rewrite it exponentially. And then we'll take care of it from there. Okay? All right, so let's zoom in just a little bit here. And we'll take a look at this number 13 problem. Now, if you have downloaded the packet that I have on the blog, then these problems are all on page 12. And then, well, these first two are, and then we'll get to page 13 as we do probably 5 to 6 total equations today. All right, so first question is, do you have that single logarithm? Do you have that single log on each side of the equation? Yes, we do. Now, what's nice about this is we have a log base 6 on both sides of the equation. Where'd my yellow go? There it is. We have a log base 6 on each side of the equation. So this is about as simple as the logarithmic equations get. We actually don't have to rewrite this equation. Since we have a log base 6 on both sides, those two simply cancel each other out. And you are left with 4x plus 4 equals 64. And then we're right back to solving a basic equation. Subtract the 4. 4x equals 60. We'll do a little division. And x will equal 15. All right, now, in our previous equations, previous unit, we talked about extraneous solutions. We still have to worry about extraneous solutions. So what makes an extraneous solution? Well, you can't take the log. You cannot log a negative or 0. Sorry, can't take the log of a negative or a 0. So we want to make sure that if we take this 15, and we plug it back into the equation, that it's just going to be a positive value. And 15 times 4 plus 4, definitely a positive value. So that makes 15 a viable solution. And we can stop and move along to the next problem. So as we move forward, we're looking for extraneous solutions. You cannot take the logarithm of a negative number or a 0. Now that doesn't mean that the answer can't be negative, we have to plug it back in to see if this right here becomes negative. Okay? All right, I'll keep you thinking about that as we move along. All right, still on page 13. So we have some condensing to do. We'll just write condense. Okay? So our 2 is going to move up, become an exponent. So will the 1/4. Okay? And the subtraction sign is going to become division. All right, so we will have single logarithm of log base 6. That'll be 4 raised to the 2nd power. And then we will have 16 raised to the 1/4 power. Let's see if we can fix that. 1/4 power. That's going to equal the same things. We didn't do anything to the right-hand side. So that's going to be log base 6 of x. All right, so think back to the previous problem. You had log base 6's on both sides. They canceled each other out. We have log base 6's on each side. So again, we have cancellation of the log base 6's, and the 6 goes too, not just the log, but the 6. All right, so we're going to do a little math. 4 squared and 16 to the 1/4. That's going to be 16. 2 times 2 is 4 times 2 is 8 times 2 is 16. So 16 to the 4th power, 1/4 power is 2. That's going to equal x. Okay, so once again, 4 squared became 16. And let's see if I can find a different color here. This 16 to the 1/4 became 2. And then the x just came straight down because the log base 6 and this log base 6 going to cancel each other out. So boom. All right. So quick and easy division tells us 8 equals x. Okay. So just check, make sure. If you take this 8 and you plug it in for x right there, is it positive? That's what we want to know. Yes, it is positive. So 8 is a viable answer. Okay, problem 14. Now, as we move to the next problem, we're actually going to move to another page. So this is page 13 inside the posted packet on the blog. All right, so we got 1 logarithm on both sides. Don't cancel it out yet. You got to do a little bit of condensing. This 4 has to move up, become an exponent to the 3. This is a pretty quick problem. Log base 5x equals log base 5. 3 to the 4th power. 3 times 3 is 9 times 3 is 27 times 3 will be 81. So we get an 81, which is from the 3 to the 4th power. That goes right there. We have a log base 5 on both sides, so that's going to cancel with that. And you can see x equals 81. We try to make sure that all of our answers are viable solutions. So make sure you take this 81 and you just look. If you put it right there, will it be positive? The answer is yes. So 81 is our answer. Check to make sure those answers are positive when you plug them back in. After that, you should be good to go. All right, let's move along. I think I've got 2 more problems. Okay, single logarithm on both sides. We do not have that. You have to condense. Okay, so what does the addition sign mean? Multiply. So we actually are going to have to FOIL the x minus 3 and the x plus 3. Okay, so we have log base 4 x minus 3 times x plus 3 equals 2. Okay, notice no logarithm on this side. So this log base 4 can't just cancel out. We have to do a little work. We have to rewrite it before we can get that logarithm to go away. But the first thing we have to do is actually do the multiplication. So if you were to FOIL these two together, log base 4, and then you get x squared minus 9. If you FOIL those together, these are conjugates. We've talked about conjugates before. You get the middle stuff cancels out. And we get 2. 2 just keeps coming down. All right, we have to rewrite exponentially. So that is going to look like this. 4 squared equals x squared minus 9. Okay, the base of the logarithm becomes the base of the exponent. The 2 is going to come and be the exponent of that base. The x squared minus 9 switches places, moves over here with the 2. That exponent, that rewriting part, is what Miss McKibben showed you guys last week. Okay, if you have any questions about that, let me know. We'll go back over it. All right, so moving right along, 4 squared is 16 equals x squared minus 9. Add 9 to both sides. 25 equals x squared. And x equals 5 and negative 5. Now, before we start circling anything, we have to make sure that both of these are viable solutions. Okay, so if we take 5, let's take this 5, plug it into here. What's 5 minus 3? 5 minus 3 is positive. I don't care that it's a 2, as long as it's positive. All right, what about here? If you take that 5 and you plug it in, 5 plus 3, is it positive? Yes, it is. 5 is an answer. Let's check out the negative 5. If I take this negative 5 and I plug it back into this right here, is it positive? No. Negative 5 minus 3 is negative 8. That makes that an extraneous solution. And only 5 becomes your answer. Only 5. Negative 5 algebraically worked, but when you plug it back in, you can't take the logarithm of a negative number. Okay? So we talked about that. Back here on our very first problem, we cannot take the log of a negative value. It just does not exist in its domain. Okay, number 16, answer is 5 only. So now you're going to be doing some delta math problems for homework. And so if you put both of these in here, it's going to give you a big red X. So make sure you know to check for extraneous solutions. Last problem of the day for you and I. We have a delta math assignment coming up after this. So we get to condense one more time. Based on the previous problem, this one is a lot simpler. Oop, forgot the 6 in there. Log base 6 just going to come down, equals, okay, the half becomes exponent of 9. 1/3 becomes the exponent of 27. The plus sign means to multiply. So I'll take this kind of slow. So we'll have log base 6. And then I'll tell you what, I'm going to put a bracket right here. We have 9 to the 1/2 power times 27 to the 1/3 power. All right, so I said I'd take this slow. Log base 6x equals log base 6 with a couple things being multiplied. All right, 9 to the 1/2 power. That means take the square root of 9. That's a 3. 27 to the 1/3 power. That means take the cube root of 27. Cube root of 27 is also 3. Log base 6x. Log base 6. Once we multiply these two together, 3 times 3 is 9. The log base 6 and the log base 6 cancel each other out. X equals 9. Check for extraneous solutions. 9. Plug back into the x is positive. So guess what? There it is. Voila. There's our answer. All right, guys, that is logarithmic equations. Tomorrow we're going to work on exponential equations. There is a mock quiz on Friday. Okay. You have a Delta Math assignment. Algebra 2, log equations. There's 20 equations, I do believe. Don't forget office hours for Algebra 2 start at 11 a.m. Go to 12, and then it opens back up at 1. Hope you guys have a great day. Hope you're staying safe and washing your hands. We'll talk to you soon.